Hello everybody. My name is Razmajevs, and today I am presenting company Eventech, and I'm going to tell you about our path to the asteroid together with ESA. First of all, uh, let me get clear with the presentation. Can you see it? I cannot see it. Okay. First of all, we are 10 employees, 8 on a technical team, 2 from business and management side. We have a turnover last year around 300K. We are doing high precision signal processing systems, basically timers, and we started in 2011. We started with I would like to point out, we started with the terrestrial applications without knowing anything about the space. We started with the satellite laser ranging. We obtained more than half of the market, but later we understood that on the Earth, so high precision is not required. And in 2016, when Latvia joined ESA as a PECS, we submitted our first proposal. We finished the project 2 years ago, and ESA invited us to participate at this scientific mission to the asteroid, which I'm going to tell you right now. This mission is called LSTM, and basically what is our core motivation is to put Latvia on a space map, because we want to know, we want that other companies knows about Latvia, that here is a lot of space technologies, and of course we want to realize and our ambitions, and we want to participate in a scientific asteroid study mission. What we are doing in this mission, we are developing a radiation tolerant timer for altimetry system. On the next slide, you can see the whole mission, what it looked like. It was going to be launched in 2 years from now, and it's going to fly millions of kilometers, and our altimetry system, where our timer is going to be based, is going to measure distance to the asteroid, because it's really important to know how far is your asteroid, because if you fly millions of kilometers and you miss it by several kilometers and all mission worth millions of dollars fails, that's very pity. That's why our very precise timer is required in this mission. If we're talking about our system, that's how it looks like in the breadboard. That's the first basically prototype. We already tested it in a thermal camera. You can see it inside it, and the results are really good. It showed that the precision is around 10 picoseconds. On the next models, we're going to decrease it and make it better to 5 to 6 picoseconds. The temperature range for our breadboard was from -40 to +60. Really good results. We do thermal calibration, thermal compensation, and a lot of different features and new systems. And future for our project is that we really want to put Latvia on a space map. Such a space mission with ESA make us possible to do this space heritage, the first space experience. They teach us how to make space projects, and it's a really great experience for us. We want to make new intellectual property which will be generated here in Latvia. We want to participate with this space experience with ESA in another commercial missions, that companies will see, okay, they did already a space mission with ESA, they really understand how it's working, they know all the standards, because ESA really teaches you a lot about the standards, how you can do it, and we want to create new products on this experience. Also LiDAR systems, like 3D scanning for wind, for imaging, gyroscopes, and a lot of other interesting systems which are required in the space, and where high precision is very important. I don't have any thank you slides, so thank you for listening to our presentation. You can drop me an email if you would like to. You can, yes, in this slide you can find it. If you have any questions, I would be glad to answer you. Yeah, thank you for your time and attention.
Thank you very much, Pavel. And taking into account that you are working on time technologies,
yes.
It's your presentation time feeling is absolutely wonderful.
So yes, thank you very much.
The question is the people are asking and really interested, and you are called like a shining enterprise in this project. What would be your advice for those startup companies who are starting up and looking to this direction? What would be the precise algorithm of steps, what to do? Share your experience.
Really, my experience, don't be scared. For example, me personally, it took 1 year just to understand what the company is doing. Another year to understand how our company is working in the space direction. And just recently, I really understood more or less like all the mechanism and everything, how it's working. So don't be scared. The space industry, yes, is kind of rocket science, but the rocket science is not so rocket science when you really spend time, you understand how it's working, because it's really interesting when you're opening a new frontier, then you're working and adding value to the science, to the new scientific openings, and then yeah, it's very interesting. It's very hard, but it's very interesting. And right now we have also an ignition event. One startup which is working in space direction. The core, like main advice to them would be, don't be scared. And also, our startup was initiated in commercialization reactor. I forgot to mention, yeah, commercialization reactor. Our company was one of the first which was initiated there, and thanks to them, also they helped a lot. They really educated companies, and it's really a great pleasure having them here in Latvia, because the new companies also will already be having a lot of expertise and advices ready, like to help them.
Thank you, Pavel,
Yeah,
very much, Eventech, and thank you for sharing your knowledge. And we are continuing our story with the next successful project, Donatas Miškinis, Alloterm. Let's give a floor to Donatas.
Hello?
Hello? Everything's fine.
Yes, you hear me. Okay, good. Let's start. My name is Donatas Miškinis, and I am Chief Technology Officer in company Alloterm SIA. And today I'm going to talk about one of our development, and this is xenon refueling compressor. Currently, we are on the stage of the engineering model and moving forward. But this is really very ambitious, very challenging project, and we are quite happy what we are involved in this activity. So, a second, I will go with. Okay. First of all, some words about the company. We are really quite small, and we still can be considered as a startup because the company founded in 2015 with two owners, myself and my partner, Igor Ushakovs, with whom we study in Latvian University physics. We decided to start this business, and this business mainly related to thermal control systems. That's why Alloterm is all about being the best in thermal management. Company, as I told, is small and growing. Today we are only 14 people, and but we are growing. I have to say, 2 years ago it was 4 people. So very important thing for us is our values, and it is here: sense of humor, inspiration, innovations, fair play, and respect for the people. So what we are doing today, two technologies are inside of the company, and we are focusing on them. First of all, it is the gas thermal compressor, and it's difficult even to find some analogs or maybe competitive product on the ground also. And mainly it's because we are developing xenon refueling compressor. But second area is more traditional, and this is the loop heat pipes, heat transfer. So it is thermal control of micro and power electronics. And what is the general for two technologies? It is the two-phase systems. So because the refueling compressor and loop heat pipes working on the same principle, we have inside of the reactors or evaporators capillary structures. And we are specialists in this area, and we are experts. So that's why it's big synergy between two areas. And if we are talking about loop heat pipes, we have another project in the frame of the PEC program. This is the loop heat pipe multi-evaporator cold plate heat exchanger, which is also a very interesting application for space. And it is based on our Alaterm SIA patent, European patent, this technology. So we have intellectual property rights in this case. I think in compressor, it will be also initiated several patents, but the project's moving quite quickly. So the name of the project, as I told, Xenon Refueling Compressor Development and Engineering Model. This is a contract with ESA in frame of PEC program with prime, or leader, engineering leader, OHB Systems. Objective is to develop the first ever xenon refueling compressor. As I told, there are no analog products on the market today. It is developed as a part of the European system providing refueling infrastructure and telecommunications model for international lunar gateway project. So it is actually a human future. Compressor by itself is a relatively small unit, only 2 kilos, but really it is the head of the European refueling model, providing for lunar gateway program. And we are quite proud what we are involved in this activity. So what is the principle? It is not very complex, actually. I'm not going to stop, but the novel technology has following features: compact design, only high purity materials, no moving parts, low maintenance cost, vibration-free operation, flexible installation, and high intrinsic safety. And very important, low operation cost. So it can be used also for terrestrial application, not only for the space. And here is the small principle, but I'm not going to stop, but it is just heating and cooling, periodical heating, periodical cooling, and in one phase we have pumping the xenon from one tank, and in another one phase we are compressing gas. And what we achieved, free engineering model of compressor have been designed and manufactured by Alaterm. Original thermohydraulic computer model for compressor performance also developed. A number of new processes and know-how, such as vacuum brazing, sintering of micro-sized metallic fibers, precision automatic welding, advanced high-strength stainless steel cleaning and cleanliness verification, and so on. We are also working on the standardization and qualification processes inside of the company. And we perform doing a lot of different setup and tooling. So right now we are with engineering models, as I told, and we are very exhaustive test campaign, which will be in future transformed, extended to the qualification program. So the compressor working as expected, even we are meeting a lot of challenges. Any new development is a very challenging task. So here just I put several photos from our laboratory. It is not the photo of compressor by itself, but the photo of the test setups and compressors inside. For instance, here you see the compressor in the performance test setup. This is the temperature and pressure cycling test setup. We are performing thousands of the cycles with compressor. And this is our vacuum chamber. We are performing also vacuum performance testing of the compressor. So the project is ongoing, scheduled to be finished in August this year. And it is, as I told, very challenging. Not everything is going smooth, but opportunities for nations to participate in such large-scale projects comes once, maybe in a few decades. And also the project opens opportunities for further advance the technology to not only to use in gateway, but also to use in commercial applications to repump the fuel tanks on the satellites. So thank you for your attention, and it was my short presentation about this project.
Thank you very much, Donatas. The question is from the audience, what is the ambition level of Alloterm? Are you considered to stay in Europe or expand worldwide?
No, of course we are quite ambitious because our vision all about being the best in thermal management. So of course we are looking worldwide. And today I have to say we have the clients all around the world. We are not producing the final product, but we are doing prototypes. But we have the clients actually in all continents, except Africa today.
Thank you very much, and we encourage you to explore Africa either, but that's in future. Thank you very much, Donatas from Alloterm, and we are switching over to the next speaker and next successful project, Kalvis Salmiņš, University of Latvia Institute of Astronomy. Let's give the floor to Kalvis. Hi, Kalvis. We see you well. We hear you well. There is something with the sound. Could you check your sound?
Sorry?
Yes, now everything is good.
Yeah. Good afternoon. My name is Kalvis Salmiņš, and I am director of the Institute of Astronomy, University of Latvia. Our project is about space debris and laser ranging. But first, I would like to introduce with our institution. Our institution is among the oldest university departments, and next year we are approaching 100-year anniversary. We have two observatories. On the bottom left, you see the Astrophysical Observatory at Baldon, and the bottom right, you will see the Laser Ranging Station Riga. Our laser satellite observation activities started during the geophysical year in 1957, when the first satellite was launched and continues up to today. I would like to emphasize that we are not involved not only for observation, but also to the technology developments, including the telescopes, timing devices, and software. About our project, multi-static space debris laser ranging capability development for SLR Station Riga. The idea is that currently there is a lot of space debris, like dysfunctional satellites, rocket upper stages, and other pieces of equipment, which creates a real danger to the currently operating satellites. To assist the satellite operators to avoid the collisions, is necessary high accuracy orbit predictions. One of the tools which can provide improved orbit predictions is satellite laser ranging. But here is a problem. Many of the satellites and space debris doesn't have laser retroreflectors. Hence, the high power lasers are required. So there was developed a scheme for ranging in such cases that the stations that operate the high power lasers are illuminating objects in space, and there are other stations who are trying to detect the scattered photons from the space object. Research shows that in such a way it's possible to improve the orbit predictions sufficiently to assist satellite operators to make decisions about collision avoidance maneuvers. On the picture of the right, you can see currently active debris laser ranging stations in Europe. The GRASS, for example, is operating space debris laser, illuminating the target, and the other stations are detecting the scattered photons. And we are with this project are planning to join to these activities. For this purpose, we have to modify our system to prepare for the debris ranging, install high efficiency detector packages, and make necessary other hardware changes. Currently, we are in the second half of the project, so we have completed most of the hardware modifications and we are ready to install them. and we hope to start the first experiments this summer. So the current stage of the project, we have completed this detector unit modification. We have made a new control unit to control the telescope operating mode. Between there we can transmit only, transmit and receive only modes. And we have to modify also the event timer software and of course accommodate the tracking workflow to our system. Here you can see, for example, detector unit. On the left side is the layout. On the right side is how it looks like during the assembly. Now this unit is completed. It will host two the photon detectors, and it's ready to install in the telescope. Here is a FPGA unit which will control the telescope optical channel commutation between the receiver modes, transmitting modes, and visual tracking. And here is example from our tracking session, which shows that we have incorporated the tracking, space debris tracking in our workflow. On the right side, you can see the ESA payload adapter. On the left side, how it we see in our tracking system. It should be noted that Ventspils is scheduled for space debris removal mission in 2025 by the company ClearSpace. Our future plans. Of course, we have planned to, in case of success, to extend our participation in this multi-static laser ranging. We seriously consider to install our own space debris laser. And we are also looking forward to satellite photometry and also to employ the high repetition rate lasers for space object and debris attitude determination. That's a brief summary for our project. Thank you for your attention.
Thank you very much, Kalvis, and audience is writing in the comments that they're definitely going to reach out for you with private questions on the development and science and issues. So thank you very much. And we are giving the floor to the next speaker, Lev Lapkis, RD ALFA Microelectronics. So Lev, the floor is yours. We are happy to hear you.
Thank you very much. Dear ladies and gentlemen, as was introduced, my name is Lev Lapkis. I represent company RD ALFA Microelectronics. I would like to share our experience working with European Space Agency developing radiation-hardened integrated circuits. It's a slide about our company. We were originally founded in 1962. In the year 2002, we became a completely private company. We are 60 people with a turnover more than €1 million annually. RD ALFA Microelectronics has more than 50 years of experience in designing and production of high reliability, radiation-hardened, and ITAR-free analog integrated circuits for various purposes. And here we present our aerospace and defense, and especially as well as special purpose microcircuits. So we are working in a high reliability, radiation-hardened triple E component market. We can offer full design and full production cycle of integrated circuits. So here I would like you to present a project that called Development and Qualification of Radiation-Hardened Quad Operational Amplifier ALFA RD124 for European space missions. This project was divided into 3 steps and 3 contracts. The third of them is currently running. We've started in the year 2015 with a research and identification project like feasibility study. The aim of this project was to identify what kind of integrated circuits from our portfolio or from the integrated circuits that we could produce are interested for European Space Agency market, for companies who are working with ESA, for the subcontractors. So we have made this study, and based on this study, we have performed the second project, development of quad operational amplifier that was most promising and needed for the market. This project was done successfully. Currently, we are running qualification of quad operational amplifier. It's a very complicated project, and today it's being done. So in the end, when it will be done, we get like stamp from authorities that say that this part can be flown. So these three stages of the project represent typical PECS and maybe RPA also approach to the project. We started with a preparatory activity. In the lowest part of my slide, you can see information from the PECS briefing. So yeah, it was first we started with a briefing, then we performed research and development activity, and we are performing right now flight segment related activities. Project overview, it was what for we have created this. The idea was to create European source of radiation hardened quad operational amplifier that would be included into the European part preferred list. This is important. Why it is important? Because there are USA producers who do something like this. It's important due to the European Commission and European Space Agency initiative called Technologies for European Non-Dependency and Competitiveness. So we have supporters for this project: Thales Alenia Space, Dainis, TROD, and Altera Technology. On the right slide, you can see motivation. For this motivation, it is a market. There is market need for quad operational amplifiers, and more than 5,000 pieces of them per year are needed. Annual cost of such operational amplifier is more than 300 euros. So we can see that there is huge market and big interest to have a European source of such integrated circuits. So results, we have developed quad operational amplifier 124, and it was tested for radiation hardness. We've performed total analyzing dose tests, and we reached 450 kRads. It is more than 4 times bigger than our competitors' level, and it is very promising. And so this kind of operational amplifier could be used not only for the satellites and low Earth orbit, but for the longer missions like mission to Mars, Jupiter, and so on. Currently, we are running qualification according to ECC 9000 standard. And up to now, everything is good. Of course, we were having some delays due to the COVID pandemic because a lot of subcontractors are involved in these. Main operations are performed at our laboratories, but also there are many other companies who are helping us to perform this and to make all these complicated tests. You can see here flowchart and some test results we have received. Yes, there are also slides showing scanning light microscope photograph of our integrated circuits. We have performed also mechanical tests of this part, and it shows that our part is in the frame of specification and can be used up for the flight. What is the future? In the future, we need to finish a qualification. We need to finish the 4,000 hours at temperature plus 125 degrees. It's like long test. We need our integrated circuits to survive it, and we are sure that it will survive. We need to finalize also the next radiation hardened test, single event test results. And finally, we need to submit documents for the European part preferred list, and we plan to do it in the end of the summer 2021. So this part is already had great interest on the market. Several engineering modules have been already sold so far to companies in Europe and outside of Europe, and market is not only Europe, but also we are seeing a great interest from such countries as India. And thank you for your attention. There are a couple of photos from our production. So our main, almost everything is being done at our own premises in Riga. Thank you very much, and I'm open for questions.
Thank you very much, Lev. And definitely, if you have questions to Lev, you can address to the contact, or within the platform, you can address also all your questions you have networking around. And we are switching over and giving the floor to Mārcis Donerblics, Ventspils International Radio Astronomy Center, VIRAC. Mārcis, the floor is yours.
Thank you for the introduction. Hello. As the introduction said, my name is Mārcis Donerblics, and I'm the project manager for ESA PECS project establishing RT16 S-band uplink and downlink RF to IF chain for TT&C service, internally codenamed RTGS. This project is currently under implementation by Ventspils International Radio Astronomy Center, together with industry partner Swedish Space Corporation. I have to apologize in advance. My presentation will be quite boring with a lot of text, but this is done deliberately for you to have maximum amount of information in case it's needed later for networking. However, in my speech, I will try to focus on our steps and opportunities with the ESA PECS program and what we have accomplished. So Ventspils International Radio Astronomy Center, it is an engineering and research institute at Ventspils University of Applied Sciences, currently employing about 80 people and working in a multitude of different fields like radio astronomy, satellite technologies, electronics, high performance computing, etc. So one might ask what radio astronomy has to do with ESA projects and space industry. Well, the two of our main instruments are large aperture, fully steerable antennas, RT32 and RT16, one of them being here in my background, which might be used as ground segment antennas and might be of specific interest to European and global markets. Therefore, actually, we have tested this and checked this within another ESA PECS project, a feasibility study. So we know for a fact that we need to move in this direction. And this is also the reason why we have the current project. So in the current project, we're utilizing the skills and experience of our R&D engineers together with the industry knowledge of SSC to develop engineering models for dual SX band feed system, as well as S-band receiver and transmitter systems and IF units specifically tailored for RT16 antenna in order to adapt it for dual use, both in satellite communications and radio astronomy. Therefore, providing two fields with state-of-the-art equipment and moving towards the new markets in emerging moon mission fields. While Latvia became the associate ESA member state already last year, this project is currently under implementation. Therefore, I cannot share the final results. However, I can show you what has been done till now, and it is a full systems concept design for this dual use application, as well as the dual band feed system design together with all necessary RF simulations, the HPA design, as well as the theoretical performance calculations and trade-off analysis in order to show that all of the requirements will be met. So at this stage, we need to actually present this to ESA and move forward with the actual prototyping. As you can see, we have taken a sort of slow but step-by-step based approach within the ESA PECS project and are now intending to continue as associate member state, which has allowed us to establish strong industry collaboration between VIRAC and SSC. Also, it has allowed us an opportunity to become a key player in Latvian space industry, already set up 2 startup companies, submit follow-on projects, and all together move us towards our ambition to become a part of European and global ground segment service providers with the mindset of providing state-of-the-art instruments to two separate industries, both radio astronomy and satellite communications. So in short, this is what we are doing. This is what we are moving forward to. Thank you for your attention, and I'm open for questions.
Mārcis, and definitely those who want to address questions to Mārcis, you can find in the platform, the Tech Atelier, and network around the Ventspils and signs there. So just do it and be brave. Thank you, Mārcis. And we are switching over to next speaker today in our successful project story session, Dainis Jakovels, Institute for Environmental Solutions. Dainis, the floor is yours. So we see you, Dainis. You're looking good, and we are waiting for your story.
Hello, my name is Dainis, and thanks for invitation to present my institution and one of our activities in Earth observation. I will start with the introduction to our institute. We are a privately established research and innovation institution. We combine both field expertise, as we usually call it, rubber boots expertise, with expertise in technologies, data science, and innovations. And we believe that the balanced combination between both of these types of expertise can result in successful development of solutions. And Earth observation and remote sensing is one of our fields of expertise also. And talking about Earth observation-based water monitoring, our motivation behind this study, this project, was related that for quite a long time, we as an institution has provided research-based consultancy service to local municipalities for improved management of lake ecosystems. And during these studies, we saw that there is really limited in situ data available from national monitoring database, because most of the lakes has been sampled only once per 6 years. And on another hand, according to Water Framework Directive, lakes larger than 50 hectares should be sampled on annual basis. And so we were starting to think how we can solve this issue, and we saw that satellites can help us to get to fill these gaps in data. And we choose Sentinel-2 satellite, which is optical one. I would say the best one in category of freely available data with the highest revisit frequency and also highest spatial resolution. And we used it for water quality assessment. We developed a model how to get from the data to the result, which represents water quality. If talking about data, on one hand, you have really high frequency of available data, because data acquisition is performed every 5 days, but due to frequently cloudy sky, there is smaller amount of useful data. But anyway, what we saw that we can expect on 1 up to 4 observations per month. And we trained the model how to get from the data, from the spectral information to meaningful information representing water quality, which is chlorophyll concentration that is further translated into lake water quality status. And we use this information for filling gaps of observations. And it is also possible to perform retrospective studies because data is available since 2015. And also satellite data is really a powerful visual tool for communication with end users. And our model was further integrated into the tool, where all available data is placed together. Data from field observations, from our own, from national monitoring database, also predictions from satellite data. And this data can be used by limnology experts to support the decision making on how we can improve the lake status. And Working with the satellite data and also assessment of water quality parameters helped us to improve scientific consultancy service provided by our institution, not only in this particular thematics, but also in all other thematics where satellite data could be applied. And as a result, we are not only like looking at one particular end user, but we are open for collaboration. And currently we have approached also ministry responsible for monitoring and then other institutions responsible for national monitoring of lakes. And it looks that they have interest to proceed with these activities and look how these results can be integrated further into national monitoring of the lakes. And yes, I'm open for questions, and if you have interest in collaboration, you can write me or call me. And, thank you for your attention.
Thank you very much, Dainis. Extremely interesting and good visual behind you on this Zoom session, also speaking on data and visualizations. If you have any questions to Dainis, you can address him directly via platform we are using and also approach him for further cooperation. And we are going to final speaker in this session, Uģis Cābulis, Latvian State Institute of Wood Chemistry. So we are absolutely happy to give the floor to you, Uģis. Hello, Uģis. There is something with the sound. Somewhere there should be sound.
It's working now?
Yeah, it's working now. Wonderful.
Once more, good afternoon. My name is Uģis Cābulis, and I'm representing Latvian State Institute of Wood Chemistry. And we are working in material science, in development of cryogenic insulation, especially for next generation European launchers like Ariane 6 and others. And shortly about our institute, we are a state research institute, and as you see from our title, we are working mainly in bioeconomy, biorefinery, but the polymer laboratory is working in our institute since 1964, and especially we are working in polyurethane chemistry and technology, both in conventional foams and polyurethane materials, and also with cryogenic insulation materials. We have a long history in this topic, in cryogenic foams. We have started to work in cryogenics since Soviet period, and we developed the cryogenic insulation for former Soviet rockets. But now more than 15 years, we cooperate with ESA, and especially with Ariane Group enterprise in Bremen, with the idea to develop the same materials, the same cryogenic insulation for the next generation Ariane launchers. As you know, the fuel for launchers is liquefied hydrogen and liquefied oxygen, and the temperature of liquefied hydrogen is 20 kelvins or minus 253 Celsius, and at these temperatures, all materials are very brittle, and these insulation materials must withstand these cryogenic temperatures and to be safe for their flight. And topic of our last project supported by PECS activity is to develop these cryogenic materials with the next generation blowing agents and with the next generation catalysts, because previous developed material is already used in Ariane 6 upper stage, but for the next future we must use new components, new ingredients for compositions, because part of nowadays used materials prohibited to use after a few years, also the motivation was to develop materials with more lower density, with the idea to save the weight of launcher, and there are some specific requirements to develop cryogenic materials with closed cell structure, with safety coefficient higher than 3, and to test what's happened with our new developed foams. when material will be vented before the launching. It is very important because all oxygen must be phased out from launcher, and foams must withstand these requirements. And yes, we have developed a lot of compositions and tested them using the blowing agents, which will be allowed in EU and in the starting since from 2023, and we find compositions which withstand these circumstances with density approximately 337 kilograms per cubic meter, and construction of launcher is very specific, and we must develop different kind of materials, but in the same time universal material which can be used on flat areas, in round areas, and especially very challenging task for us was to develop foam materials, as you see, for this white type ring, because it is very narrow angle, and foams must withstand with perfect adhesion to both sides of this angle, and because cryoshock is very dangerous conditions for materials, and these problems was solved, and no material is going for the next test, not in our premises, but also in ESA premises, with idea to introduce them in the nearest future. And our future plans is, yes, to work in the same topic, cryogenic insulation, but also to use more and more environmentally friendly raw materials from renewable sources. One challenging topic is work with non-isocyanate urethanes. In this topic, we have cooperation with the Czech company Tosida. They are working also in polyurethane business and technologies, and they are partners of ESA. And also, we cooperating with Latvian SME cryogenic and vacuum systems, with the idea to develop original test equipment for testing of our developed materials at liquefied helium temperatures. And as you see, we are open for next activities, for develop the next generation cryogenic materials, and we are active in this topic. Thank you for your attention.
Thank you very much, Mr. Uģis Cābulis from Latvian State Institute of Wood Chemistry, and definitely you can contact Uģis if you have any questions, comments, or cooperation interests and possibilities. So thank you very much to Uģis.